Thank you very much for the introduction, Sarah. Good afternoon, ladies and gentlemen. So, I'm Pasidu Pallawela. I'm the Chief Technology Officer and Director of Stortera. So this is my 10th year working for Stortera, I think. That's a milestone, actually. So I worked for companies such as Siemens and General Electric's Advanced Technology Group before joining Stortera. Stortera is an Edinburgh-based energy storage innovator. So we design and manufacture intelligent energy storage systems here in Scotland. And in parallel, we are commercializing a new storage technology called, it's a new battery technology called the single liquid flow battery. Now, the single liquid flow battery is kind of mainly focused at industries like data centers. So we have quite a lot of experience working with telecom companies and data centers because by about 2019 we have exported almost 100 systems to various parts of the world, especially targeting telecom and data center applications. So the reason why we are here today is to basically explain how this new single liquid flow battery can help data centers to reduce their costs, and also how these new batteries can help them to become more sustainable. So it's going to be a little bit of a technical deep dive. So yeah, brace yourselves. So right, before talking about the single liquid flow battery, I would like to kind of discuss about the pain points that data centers have at the moment with regard to energy. So number one is obviously rising cost of energy. And then data centers have these sustainability targets. I think Alia mentioned a little bit about this. About 1% of energy consumption in the world goes into data centers. But if you look at the numbers of global electricity production, 5% by 2023, 5% of the global energy production, electricity production goes to data centers. So that's a big number. If I'm a climate activist, I would just definitely target data centers. And then on the other hand, hyperscale data centers such as Microsoft, Google, Amazon, those guys, they claim that they're using close to 100% renewable energy. So that puts pressure on other data center operators to be more sustainable and to use more and more renewable energy. So that's another pain point they have. And then there's a massive drive in the data center industry to reduce the total cost of ownership. Data centers, they don't I'm sure there must be some people from the data center industry. They don't want to own their energy assets because it's not just capital costs. It's maintaining them, looking after breakdowns, looking after the operations. So there's a drive in the data center industry to reduce this total cost of operations, which is another pain point. And then the elephant in the room is managing the waste heat. So if you look at the total energy consumption of a data center, about 30 to 40% become heat. So you have to reject that heat. So if you can use that heat for something useful, that's a game changer. And then another pain point is improving efficiency, because there's quite a lot of pressure on data centers to improve efficiency of their energy systems. This is one of the key buying decision drivers after reliability. So if you can do something about improving efficiency, that's going to be a great win for data centers. But even though this looks like a cloud, there's a silver lining in this kind of dark pain cloud, I would say, because data centers have large amount of batteries connected to UPS systems or uninterrupted power supply systems, and because they have large grid connections, there's a possibility of earning grid services revenues using these idling assets. So new battery technologies like the single liquid flow battery can enable this. It can enable them to reduce costs by earning revenues, and also batteries can help data centers to be more sustainable. So let's see like how smart batteries can help, especially batteries like the single liquid flow battery can help data centers to become sort of profitable and more sustainable. Number one is grid services revenue. I don't know whether the audience know much about grid services revenue. Basically, what's happening is, if you take Scotland, we have so much wind energy installed in Scotland. So when the wind blows, we can't use all that energy. So obviously, like the grid is imbalanced. So we need to, if you're connecting a lot of renewable energy resources generation into the grid, we need to balance that grid. So energy storage is an amazing asset when it comes to balancing the grid. So if you can make energy storage available to balance the grid, you get paid money. You get national grid will pay you money. So that's what you call as grid services revenue. So because data centers have these large grid connections, and if they can use battery technologies like the single liquid flow battery, there's a good opportunity for data centers to convert those cost centers to revenue generating assets. And when you use like large battery banks like the single liquid flow battery, you can use energy arbitrage because most of the data centers buy energy from the wholesale market. So you can buy energy when the energy is cheap and then kind of use it during the times when the energy is expensive. And having large battery banks on site can increase generation of on-site renewable energy. And then that reduces energy costs and also increases the sustainability of data centers. And then if you take the particular case of this single liquid flow battery, these new battery technologies are much more efficient than the older battery technologies. For example, this particular technology is about 96% efficient last time when Power Networks tested our system. So using this kind of batteries can increase the overall efficiency of data center energy assets. And then another advantage of these new battery technologies is it enables novel business models such as energy storage as a service. So these kind of business models can reduce the total cost of ownership. So what happens is you don't like pay that upfront money to buy a massive battery, but you just pay something for the availability of the battery. So these new battery technologies can enable new business models as such. And then because of all these revenue generation and cost savings, these new battery assets, their return on investment is very strong, typically around 5 to 6 years. So these are like some of the advantages of single liquid flow battery being used in data centers. So before I deep dive into the technology, I'm going to quickly explain like the current product range of Stortera. So in the left-hand corner, what you see is our store tower. That's a domestic and small commercial energy storage unit. It can handle anything from about 2.5 kilowatt hours to about 50 kilowatt hours. And then when it comes to grid scale large installations, we have our store hub product. It's a kind of containerized megawatt scale product looking after large clients. And then we have our own artificial intelligence based control and monitoring platform called Tricon. Tricon stands for Tri-Layer Artificial Intelligence Controller. So this unit is a battery chemistry agnostic control and monitoring platform. So what these systems do is they increase the impact of energy storage systems installed in sites. And then in the right-hand side corner, what you see is the single liquid flow battery. So that's the battery storage system that we have developed from scratch. We have patented this product in the UK, North America, and a few other locations. So we believe like this is going to be the game changer for the next few coming years. So I'm going to like quickly, very simply explain what this new battery technology is. So what you see on the right-hand side is a 25 kilowatt, 200 kilowatt hour flow battery module. So we call it as a 8-hour battery. So these are like long duration batteries, not like our small lithium-ion batteries, which are normally 1-hour batteries. These are long duration batteries. So on the left-hand side, what you see is a schematic of the single liquid flow battery. Now, let's see what a normal flow battery is. So a flow battery is made by converting the anode and the cathode to liquids and then storing it away in tanks. So you have like large 2 chemical tanks and something called a flow battery stack. So if you want to charge or discharge the battery, what you do is you pump those liquids through this flow battery stack. So typically, traditional flow batteries like vanadium redox flow batteries, they are like low in energy density. They are very capital intensive, but they can work for a very long duration. So these are like good bankable assets, but the initial capex, the initial investment is the main problem. So what we have done in the single liquid flow battery is we have just converted the cathode to a liquid, and then we can store it away in tanks. But this liquid is highly energy dense, very safe, and durable. So because of these reasons, we have managed to bring down the cost of this battery, and we use very economical material. 70% of the battery is sulfur, which is a very, very cheap material. And it consists of something called spiral flow cells, which can be manufactured using roll manufacturing technology. So the manufacturing cost also has brought down to enable to bring down the capital cost of this technology. So I will quickly kind of show the main features of this battery and why this is pretty important for industries like data centers. So this is like a quick, like a schematic representation of a single liquid flow battery, which we can use for the data center industry. So the main feature is this technology is very safe. The reason is the main liquid can work in a wide temperature window from minus 25 degrees Celsius up to about 120 degrees Celsius. So we don't use any flammable liquids, or they don't self-ignite like lithium-ion batteries. So because of that reason, the fire risk is very low. And then because the active material is stored away from the main stack, there's no current flow risk. So current flow risk is a major problem for data centers, for example, when you try to install large batteries. And then it has low levelized cost of storage. What's levelized cost of storage, or LCOS? LCOS is a key metric which you use to compare different battery technologies. So what this means is how much does it cost to store a kilowatt hour of energy? So in our case, it's about 1.3 pence per kilowatt hour. So if you can bring levelized cost of storage down to this level, this can truly enable widespread use of renewable energy, because you can store it cheaper than getting energy from a gas turbine or from a diesel generator. And because we are using spiral flow technology with low manufacturing costs, our capital costs are quite low as well. And then the third feature is sustainability. Because we are developing this from scratch, this is a battery developed as a sustainable technology. So I showed that it mainly consists of a liquid liquid. So 90% of the material is liquid, and it is 100% reusable after its lifetime. And then rest of the material are all recyclable. So it's a technology which is very sustainable. And the other feature which is quite interesting for data centers is the ability of making this a redundant technology. So redundancy is a big thing in data centers. For example, when we talk to data centers, they don't like their battery banks to be used for grid services. So what you can do in that case is you keep one liquid tank for your backup, and then you have another liquid tank for your revenue generation. So in that way, you can build up redundancy as you like. And then the other feature is, I mentioned like this liquid works in a wide voltage, wide temperature window. So when you have like these large tanks of liquid, part of that rejected waste heat in data centers can be absorbed by this liquid. So if a battery can be operated at a slightly higher temperature, the efficiency goes up. That's a known feature, but unfortunately, our phones or batteries in our cars can't do it because they'll just catch fire. But we are not using water or flammable liquids or solvents in this battery. So because of that, we can go up to higher temperatures, absorbing that part of that waste heat. And also, you can use heat for circulating the liquid through this system, through this flow battery, using thermosiphoning. So when you do that, you can shut down the pump and increase the efficiency of the whole system. And another feature of flow batteries or of this particular battery is long duration capability. Now I explained before, if the lithium, like lithium-ion batteries or lead-acid batteries, they are quite short duration batteries, maximum 1 or 2 hours. Whereas these batteries, especially flow batteries, can go up to like 8+ hours. So when you have that capability working for 8+ hours, you don't really need diesel generators as backup, because that's a good backup itself. Long duration batteries can be very useful for data centers to be sustainable. And then the last and the most interesting feature is cycle life. These batteries, especially flow battery technologies, can work for more than 20,000 cycles plus. That means these batteries are bankable assets. If you have like a battery which only works for like 5 years, these assets are not bankable. When an asset works for 20, 30 years, then that's a bankable asset. So that's what we bring in into this data centers using this battery technology. And the efficiency obviously is around 96% for these batteries. So with all these features, we truly believe that single liquid flow batteries will make a step change in the energy storage industry in the future. So this is a quick picture of the production, small roll production line. So as I explained, we use spiral cells in our flow battery. We are the first roll. So we are the only age because of IP issues, but this is generally like, this is how our installation would look like. So this is like an installation that we have done for Perth and Kinross Council. It's connected to a smart pilot smart grid, connected to solar PV, maximizing solar PV generation. And also this installation uses artificial intelligence to optimize EV charging and heating. So I think Sarah mentioned about a project that we are doing currently. So we are building a 1.6 megawatt-hour flow battery to be installed in Midlothian Innovation Centre in Edinburgh. This is like, it will consist of multiple flow battery modules. It will be used for these grid services to prove that these batteries are pretty much capable of earning grid services revenue. And then this will be an 8-hour battery, as I mentioned before, a long duration battery. it will be mainly using renewable energy and will be used to sort of perform energy arbitrage as well. So that's the current project that we are doing. That's the current big project that we are doing. This should be installed in Midlothian Innovation Centre by the end of 2024. So I'm not going to take too much time. So this, I'm going to conclude my presentation after this slide. So just to recap, why single liquid flow batteries can make data centers profitable, and why they can make data centers more sustainable. So number one is like, single liquid flow batteries allows data centers to earn grid services revenue, and then it can get data centers lower energy prices using arbitrage, and then it enables on-site renewable energy generation. Because it's a long duration battery technology, it allows data centers to replace diesel generators, and because of all these savings and revenue generation, the return on investment is low. And most importantly, new battery technologies like the single liquid flow battery enables new business models like energy storage as a service, which reduces the total cost of ownership. And lastly, this particular flow battery technology can absorb part of the generated heat, which improves the overall efficiency of data centers. So with these features, we truly believe that single liquid flow batteries can make a step change in future data centers. So with that remark, I would like to conclude my presentation. Ladies and gentlemen, thank you very much for listening. And if you have any questions, please ask now.